Okay, this is the mission 52 organized by the Space Analog Station at Marte. And today we'll be talking about the main station. Okay, and then these some topics that we'll be discussing during this presentation. And here we have the map of the location of each infrastructure in proposed Mars habitat in future operation. We have the launch center, the main station, the health facility, the greenhouse, the sanitation center, engineering center. And then you can see the power station connected with MOXIE. It's the as a technology that is be transported to Mars in the Perseverance rover. Also, we have the solar farm, also the kilopower energy plant connected to the power station. Okay. Then in the this was a design based in the previous missions, and this design was done by Yash Rato from India. And then we can see each facility conceived as a unique infrastructure. In this case of main station, we are considering Habitat Marte uh, after these conceptions, maybe like three circular or hexagon uh, connected. Okay, and then I now will be present some idea about the internal design. This was a proposition of Yashrato. Okay, and then we believe that in, in his propositions, this would be a good idea. Maybe of these beds in if you are imagining a specific facility. But in terms of the main station, we imagine a main station that a place like a convenience area, a place that all crew members would be together during the sleepy time. And then based in this, we are imagining a station for a quantity of astronauts around 26 to 30 astronauts, okay? And because we are imagining all the astronauts sleep together in main station, and also using the other stations as necessary, okay? We imagine the in each facility have also beds, okay, and also a small kitchen because we are during these missions we are imagining the possibility of a virus in the station. The virus would be identified uh, based in sensors collecting the quality of information about the quality of the air, and then the sensors identified the possibility of a possible threat, a biological threat. And then because of this, in the specific facilities, we imagine the necessity of beds because if happen the situation like this of a virus, of a bacteria, the astronauts would be locked in the specific facilities, okay? And then uh, this design proposed by Ashrato is not present enough beds to all crew. Okay, because we need something like 28 beds. Okay, and then this the some facilities that we are imagining for the main station, like the control center, management and communication, also dorm, also training room, also dining room, kitchen, a gym, spa area, recreational area, the research room, and then a small vertical garden with plants for meals. And then we can see a general possibility of design. The importance of the plants also brings some humanity to the station. Okay, Also, part of these plants would be used to be consumed as food. Okay, and then you can see a general concept of a control center with a lot of screens of multitaskings resources. If you look at the travel of Dragon, the Dragon capsule to the International Space Station, it's possible to see uh, the tools of the control of the mission. They use computer screens to control the travel to International Space Station, and then it's very different when you see the other control panels using in the other missions from NASA to the computer screens used inside the Dragon capsule. Okay, and then I believe that they will be using like computer screens like this to control many different systems operating in the Mars habitat. Okay, and then the research room will be a facility to make analysis of the possible bacteria, or it's like a scientific center. It's also to control some biological and also the analysis of the spacesuits, because spacesuits will be contaminated by Mars dust, and the Mars dust is very sharp and also cutting the fabric of the spacesuit. And then this necessary analysis of if the how is damaged the spacesuits, and also parts of these activities would be developed inside the research room. Okay, also sometimes do analysis of the Mars soil and some Mars rocks. Okay, all part of these activities would be developed in the research room. This is the conception of the dorm with also with small shelves. Okay, and the kitchen. We saw a company called Molly.com, and then they created this robot. It's the first robot kitchen, and then you can see the robot taking some food here to prepare a meal. Okay. Also in the left side, you can see like a screen with a person explaining how to prepare the food, something like this. And then would be interesting. We have some tutorials how to prepare food, specific food in Mars. Okay, and also the support of this robotic technology. Also, this is the possible concept of the dining room. Also, the gym, and then this was a proposition from a Brazilian student of architecture. Her name is Mariana Guerra, and she proposed a very interesting concept of three infrastructures together. Uh, okay, it's like hexagons, and then the name is alpha, beta, and gamma. And then alpha would be like a silent sector for rest. The beta is a medium use, is a social and a leisure sector, and the third one is gamma, is extended use of scientific sector and for work. Okay, and this and then in our imagination it's not enough one area, but three areas together. Okay, and then you can see the alpha model here. It's possible to see the bedrooms, the study room, rest room, also bath, all everything here, okay, in terms of comfort of the astronauts. And then in beta module, it's possible find kitchen, dining room, and living room, also the gym, okay, and also the entertainment area here. And the third one is gamma model for training, control, and research room. And then, if you remember our proposition in the beginning, we imagine that each model like this will be presenting three levels, okay, like this, three levels. And then in alpha model, the first one, we imagine 13 bunks for 26 astronauts, okay? And then 5 bunks in the second and third floor, and 3 bunks in the ground floor, okay? Also 26 luggage storage, 2 bathrooms, and 1 study area, okay? And the second one is beta model, is presenting kitchen, dining room, table for around 10 persons. Also, the second floor will be presented living space, and third floor the gym. Okay, and then we imagine turns of the for dining and also lunch. Okay, and then turns to because the area is not big, and then we we need some like some uh, turns to specific times for part of the crew, okay, to be lunching, okay. And the third floor or the third model is the gamma. Is he in the ground floor will be operating the research room, the second training room, and third the control room, okay. And then some applied technologies that we imagine to space. We also will be writing here also the communication technologies. Okay, we'll be adding here. Sorry. Also, in this area in main station we will have technologies as oven, fridge. Also, we imagine the virtual reality red sets. Also, bathtub, spa, hydro massage massage, disco lighting, also communication technologies. All of these will be operating in the main habitat. Okay, we are imagining some uh, entertainment resources for the crew. Okay, in the main station. Also possible resources to generate in situ or transported from Earth. We imagine that almost everything will be transported from Earth, but we imagine that part of the food would be produced in the greenhouse, okay, the facility of Rouen that would be supporting the, uh, the the operation of supplying food for the crew, okay. And then now we'll be talking about the second dimension is related to the management of this facility, the main station. We imagine the 4 positions: the commander, the executive chief, the chef, and general assistant. And then, okay, and then the commander, he will represent a multidisciplinary background. Maybe it would be a person with a background in management or industrial engineering, as maybe someone with a high capacity of leadership, also high personal resilience. And some duties of the commander is the control of extravehicular activities, the EVAs and the rovers, also propose routines and operational protocols, also provide the guidance to avoid risks, also conduct educational activities and training astronauts, preparation for EVAs, also coordinate daily communication routines with NASA, ESA, or ISRO, or other space agencies, if related to Earth Mission Control Center. Also coordinating communication with facilities, the crew, and sometimes communication specific to each individual. Okay, some part of these duties maybe would be developed by other members, like the assistant. Okay, and in the main station. Okay, and the second one is the executive chief. This person would be an engineer with a background in information technology and communication. And then some duties of this position would be he would or she would be monitoring all operation, keeping all facilities running, monitoring routine maintenances, organizing specific operation and responsible people, coordinating training. Sometimes these trainings are online content, sometimes are meetings, sometimes are classes. And also this person will be keeping all the facilities running, organizing specific operations and responsible people, stimulating self-sustainability. That means that each one is observing self in organization, self-maintenance, self-fixing, and alerting other necessities of fixing some problems. And then the third one is the chef. Okay, he would be a cooker or a nutritionist or a cruising chef. And then some duties are define menu, define the meals and food logistics, perform food preparation, waste disposal, cleaning, organization, maintenance, and repair procedures, assess the team's nutritional requirements, plan the availability of food, and define the feeding shifts. Okay. In terms of this last element, you can see a image from the Matrix movie. In the Matrix movie, in this photo, we can see the Neo or Thomas Anderson looking the meal inside the Nebuchadnezzar ship. Okay, and he is consuming all days the oat. Okay, and then it must be very boring. You're consuming all the same meal all days in your life during Mars time there. And then one of the challenge is of the cooker of the chef is prepare interesting meal. Okay, and then you can see here the a photo showing the meal pre-prepared in earth and transported to space. Sometimes these are dried food. Sometimes you need in International Space Station they need to put hot water inside this plastic package, and then with hot water this food become hydrated, and then I believe it's a good thing. And then in this third picture is some food collected in the habitat matter. You can see pepper and lettuce, and also the basil collected in habitat matter. And then just to remember that part of the food will be produced in the Mars habitat. Okay, and then this is interesting because we need to combine this food, the quantity of food or the necessary food transported from Earth. Okay, or and what kind of food will be produced in Mars, and then this is a great challenge. We imagine the quantity of each one. Uh, the food necessary to be transported from Earth and the food produced in Mars. And imagine this in terms of also the safety for the astronauts. Okay, because if you are transported from Earth, if presents a problem during the transportation, the people not will have this, and then maybe they Also, if also be dependent from the food produced in Mars. If you have a problem in the greenhouse, it also would be very dangerous. And then we need to reflect about these two possibilities and not be dependable of each one. And then the last positions, the assistant, this person would be an engineer or someone with information technology, someone with skills related to well-being, and then there's some duties are to emphasize the team's well-being, create interesting content to entertain the team, food management, support the chef, coordinate the organization of the dormitory, coordinate the gym, also manage laboratory tools, study routines, sample analysis, and also be doing doing the follow-up of the psychological aspects of the crew. And then we imagine a astronaut training program for the members of the main stations. This training program would be based in the new skills based in situations identified in Mars, also systems operation, also testing and training of new technologies, also training about the positions, tasks of each astronauts, and simulations. And then we identified some videos related to the main station. And it's also interesting. You look in the internet that some videos, interesting videos related to your facility. Okay, in this case, we found a video about make things work. Another one is about mental health. The third one is about operational safety and health, and also a last one was a building resilience, but would be a bigger list, okay, related to the facility that you are studying. That's you YouTube videos that can be used to train astronauts to that will be working in your facility. Then resources necessary for 1 week, we imagine like 1 kilo by day of food, or sorry, is wrong here. It's a 2.5 liters by day and 1 kilo of food by day, and also 2 liters by day for each astronaut. Okay. Some guidelines to other facilities. We imagine the mental well-being, entertainment, daily routines, scheduled activities, healthy occupation, also the health and environmental safety guidelines, also guidelines related to how to maintain plants in specific space habitats, provide harmony and collaboration, make astronauts comfortable about to be in space, stimulate cooperation, innovation, creativity, and co-creation, emphasize the well-being in the crew, create interesting content to entertain the team, stimulate self-sustainability. Okay, and then now we'll be talking about the third dimension is the protocols. And then the protocols are related to the some specific protocols to the applied to the main station are the protocols for harmony and good relationship, also protocols to deal with stress and relationship, protocols to organize the room, protocols for plant maintenance, also protocols for food production, infrastructure maintenance protocols too. Okay. In terms of the protocols of safety, we imagine the hygiene protocols, sometimes protocols related to health data collection using wearables, sometimes using Apple Watch or to identify heart rate or heartbeat, calorie consumption, physical activity level, saliva, blood, feces, and urine samples, and also protocols for dealing with psychological emergencies. So also protocols and simulations to deal with accidents. And then some possible protocols related to safety. Some protocols related to occupancy and entertainment. Sometimes we imagine the parties like the Christmas or other specific national day, like that. If you have a important day celebrated in India, and then if you have astronauts from India in the Mars habitat, what will be the most important day in the Indian calendar? And then this day would be celebrated in Mars, because it's very important these activities to remember that the astronauts still humans, okay? And then it's very important to remember important moments or uh, memory of the important moments in Earth, okay? And that is very interesting. Also, we'll be celebrating the birthday of the astronauts, and then all this need to be imagined, because this would be very interesting to keep the good emotional levels in the mission. Okay. Also, use of body games or video games too. Also, and competition between the members. Also, yoga and physical exercise protocol. Also, the suggestions of literature to read. Also, other content. And then there's our imagination of vertical garden. Yesterday during Habitat Marte, we talked about the hydroponic system. Possibly this is a hydroponic system because we are using the nutritive solution. Okay, part in Mars, part of the nutritive solution would be provided by sanitation center. Okay, from the processing of uh, the composting processes developed in sanitation center, and then will be developed the a nutritive solution to this to be applied in this hydroponic system. And then related to the protocol for food microproduction, we have the possibility of the first of all a protocol for cultivation of the food. The second one, a protocol for maintenance of this cultivation, food plants cultivation, and detection of adjustment, management of the plant. The third one is the collection protocol. The fourth is the a protocol for rotation and disposal of the discarded plant, because some plants are present like a 6 month cycle, and then sometimes necessary to cut the plants and add a new plant in the bed, in the grow bed. Okay, and then it's necessary to identify the best time for irrigation or some automation processes for irrigation of the plant. Sometimes male and female flower pollination, and also reflect about the plant cycles and plant lifespan. Related to the protocol for 3D printing, here we can see a 3D 3D printing process using the clay, okay, using clay to produce the ceramics, okay. And then in the main habitat, if you imagine that we have dishes, cups, and also fork and knife, something like this, maybe 3D, the use of 3D printing in the main facility would be used to produce some tools, okay. And then all the examples of tools based in plastic, based in ceramics, and then some protocol for 3D printing, and then possibility to print some utensils like plates and mugs, okay? And in this case, it's necessary a great list of items to be printed, as well as the CADI projects, okay? And then we have also proposing a protocol to degradation of the product, like the crushing of discarded items, preparation of pallets, and preparation of filaments for 3D printing, and at least the printing processes. Okay. And then the last part of this presentation is related to the spin-offs. Okay, spin-offs are some possible solutions to be applied in Earth. Okay, and then we imagine that some possible 3D printing applications would be applied in Earth. Okay, also some guidelines to be applied in daily lives in Earth, some discussion, some practice in Mars related to mental well-being would be applied in Earth. Also, during the COVID times, I saw a lot of lives uh, done by astronauts. They talking about how is to live in confined environment in space, and then they teach it to. They presented guidelines to Earth how to deal with this moment of coronavirus. This was very interesting. Also, the learners in space would be provide guidelines related to daily routines, also health occupancy, also health environmental safety guidelines. Okay, applied to Earth. And then, as a last aspect of this presentation, is related to some how the activity of the main station would be impacting the sustainable development goals. And then also we can imagine that will be some learners would be providing guidelines about how to save energy. Okay, also how to save water, how considering aspects of recycling is related to goal 15. Also, we can imagine that also gender equality is important topic, maybe in the main station related to the four members. If maybe it would be interesting to have two women and two men working in the main station. Okay, between the four positions considered to that. Okay, and then this is not I some reference were presented during the presentation. Okay, and then this is my contact. Also, more information will be possible find in our profile, Habitat Marte. Okay. Okay. Thanks so much. Stop here.